your name.
Ryland Grace. I just woke up from a coma. I'm several light years from my apartment. And I'm not an astronaut. I'm not an astronaut.
Please state your name.
Ryland Grace. I just woke up from a coma. I'm several light years from my apartment. And I'm not an astronaut. I'm not an astronaut. I'm not an astronaut.
If you don't go, you die. With the rest of us. The sun is dying. You are the only scientist who might know what this says.
I'm just a teacher at Grover Cleveland Middle.
You have a doctorate in molecular biology. I need you to come with us. This is Project Hail Mary. The sun is not the only star dying. Every star was infected by its neighbor, except one.
Why?
We don't know.
Which is why we built a ship to go there and find out.
It's 11.9 light years away. The astronauts die in space.
It's what you Americans would call a long shot.
Hail Mary. I get it. Who on earth is going to sign up for this?
If we do nothing, everything on this planet will go extinct.
You'll find a solution.
You are my solution.
I put the knot in astronaut. I've never done anything. I've never done a space. I can't even moonwalk. I understand the stakes. I do. But my place is in the classroom.
The world is counting on you.
This might be very hard for you to understand. But some people are not good at things.
You know who you are. You're gonna do great.
I conquered zero G in 5 hours. Yeah!
Object approaching.
Oh my God. So, I met an alien. He's kind of growing on me. At least he's not growing in me, you know, which was a concern for a little while. I'm Grace. I'm gonna call you Rocky. Thumbs up. Nope, that's thumbs down. We do the thumbs up. It's close enough.
All right, a little something to set the tone for tonight. So in movies like Project Hail Mary, the future of humanity often depends on a few scientists and engineers who are willing to tackle impossible problems. The story is fictional, but the mindset behind it is very real. And that's exactly what tonight is about. So all around this room are founders, engineers, researchers, investors working on technologies that push beyond Earth. And from robotics and radiation protection to wireless power and deep space systems. But the interesting thing about space technology is that it rarely stays in space. The innovations created to survive in orbit or explore deep space almost always come back to improve life here on Earth. And that's why tonight matters. Because the people demoing tonight aren't just imagining the future, they're building the technologies that will shape the next era of exploration, infrastructure, and discovery. So with that spirit of exploration and innovation, welcome to the New York Tech Meetup, Spacetech Edition. All right. Hey everyone, I'm Doug Bennett, Director of the New York Tech Alliance. We have a great runner show tonight, but before we get to the demos, I have a few items to share. So please know that we're recording tonight's event, and we'll be posting the video within a few days to the NYTA YouTube channel. You can subscribe to our channel and view this and past recordings by going to youtube.com/NYTech-Alliance. Also, Zeotag, which automatically indexes them, so you can search and jump right to the parts you're most interested in. It also makes our content more accessible for people with hearing and vision disabilities. To see how it works, just scan the QR code on the screen, and be sure to say hi to Jeff Paul, the founder of Zeotag. He's here tonight at the back table. Hey, Jeff. For anyone new here, the Tech Alliance is a nonprofit that connects the New York tech community throughout the 5 boroughs and beyond, and has a global reach. We're part of Civic Hall, and we're all a part of FedCap, a historic nonprofit that dates back to 1935, when it was founded to help disabled vets get jobs. Through acquisition, today we're a family of 42 companies operating in the US, Canada, the UK, and now Australia, focused on 4 areas: workforce development, education, health, and economic mobility. So Civic Hall occupies floors 1 through 7 of this building. It's about 85,000 square feet. We do 3 things here. We're a digital skills training center to help a wide variety of people get jobs in the tech industry. We have an event center on floors 2 and 3, and we provide membership for both individuals and organizations. The infographic on the screen shows our member diversity and the reach of our community here in New York and globally. So to learn more about us, go to nytech.org. And tonight, Civic Hall is providing a free member trial to everyone attending this evening. If you'd like to give it a try and see if this might be a good place to work from and be part of the community, scan the QR code on the screen and submit your info. We'd love to welcome you. Okay. Thanks to our annual sponsors who help make events like this one possible. With us tonight, we've got Michael Fainberg of Arid & Fox, who's back in the Table 9 back there, Paul Ellis and Camille Gallardo of Ellis Law Group, and as mentioned earlier, Jeff Paul of Zeotag. Each has a table, and I encourage you to stop by and say hello. All right. Okay, so how many of you are attending a New York Tech Meetup for the first time? Okay, quite a number, nice. So for all of you joining us for the first time, our meetups are all about the tech and the market opportunities each company is addressing. It's not about the business or revenue models. Okay, those conversations can be had during networking time or elsewhere. So during the Q&A, please keep your questions to the tech and the problem or opportunity it's addressing. If not, you're likely to get booed, okay? All right. So tonight, each company will have up to 4 minutes to demo, up to 4 minutes of audience Q&A, and a minute or so to pose and ask offer. And given tonight's tight schedule, we have a countdown clock here in the front to help everyone stay on course. And if anybody goes beyond that limit, they'll be kindly prompted to wrap up, and allow all of you to ask your cues, all right? Okay, so tonight we have a special meetup edition focused on Spacetech. We've reconnected with some wonderful friends and partners and welcome new ones in the Spacetech community. And I first want to thank Malcolm Biggins of Campus Climate Tech and the catalyst. He's been the catalyst for this whole meetup. Spacetech wasn't even on my mind until Malcolm called this past fall to talk about it, and also about an event he was producing, and to share his thoughts about future Spacetech programming. So within a short time, I had additional calls with Devin Nathan of Defense Entrepreneurs Forum, Evan Lerner of Empire Space, and Walter Shanizon of Uplink, each who helped curate tonight's demos and who will step up to talk about their respective organizations and introduce the demo teams. Tonight kicks off the work we're doing to spotlight the amazing people and Spacetech products being developed throughout the boroughs, and also to heighten awareness of exciting new areas in workforce development. So with that, Walter wasn't able to be here in person this evening, but we do have a brief message to share from him about an upcoming business summit designed to bring together Spacetech companies and the capital they need to grow and scale. This event, plus others in development, are part of the ongoing effort to grow and scale this sector within our system.
Hi, everyone. I'm Walter Charnazon, co-founder of Uplink, the Spacetech Business Summit, coming to New York City in October. I first want to say thank you to Doug Benet and the New York Tech Alliance for putting this evening together, as well as to Evan Lerner, the director of Empire Space, and a member of the Uplink Advisory Board. Uplink is a curated business summit that will be held in New York, and its purpose is to bring together space tech companies with the capital and customers they need to succeed. Attendance is by application only and limited to 200. You can learn more about the program from Evan this evening by visiting our website at uplinksummit.com or by reaching out to me directly at walter@uplinksummit.com. I hope we'll see you in October, and have a great evening tonight.
All right, thank you, Walter. So please reach out to Walter if you are interested in participating, okay? And for the record, it's Benet, not Benet, so you're not. Okay, so I'd like to welcome Malcolm Biggins, co-founder of Campus Climate Tech, a wonderful community partner and an integral part of NYTA, to say a few words about Campus Climate Tech and kick off tonight's demos. Hey, Malcolm.
I want to just thank Doug over here. Once you start coming to these, you can't stop. These are the things I look forward to every month. The New York Tech Alliance is truly an amazing asset to New York City and the innovators here. So Campus Climate Tech, I want to tell you a little bit more about what we do, and please take a second to scan our QR code here. So universities are the primary drivers of US innovation, but they're often siloed, and funding for academic research is tightening, especially in recent years. While there are many cross-university initiatives, few truly connect the research and innovation communities themselves. Campus Climate Tech brings together university innovation communities to spark cross-campus collaborations on research, as well as helping innovators access key resources that are inaccessible otherwise, and to accelerate the pathway from lab to market for those who wish to take their research and bring it into the real world. So this is a community for faculty and student researchers and the startups that have spun out of universities to come together, share what they've learned, and to help pave an easier path forward for these technologies that are really impactful but hard to build. And tonight we're focused on Spacetech, which I believe is the original climate tech. It gave us the tools to really understand how our world is changing and to do many things. And so today's about the intersection of space tech and climate tech in many ways. And this is a good transition for my next hat, which is for the Columbia Climate Fund, where I'm currently a student. We've developed a fund to bring together the innovation community, the alumni community, and industry to help bring to bring Columbia innovation to market faster and to provide the resources it needs. And this is a student-led initiative. We are students from the business school, engineering school, policy school, bringing in a multi-school perspective to find great startups and help them succeed. So you're going to hear from two teams tonight that spun out of Columbia, both our Columbia-affiliated founders, that's YANKTECH, as well as Icarus Robotics. And we're particularly excited about how space and climate tech intersect. And so one last thing I want to share with everyone is please follow us again on this separate QR code, and we will be raising our fund in the coming months. So if this sounds like an interesting area, please come find me. Please come find me after this. We'll talk. Okay, so I want to welcome Josh Yank of YANKTECH to start things off. Please, Josh.
Thank you very much. Really appreciate being here tonight. So YANK Technologies is a wireless power developer and innovator based in New York. We focus on providing power over the air and while devices move in real time. Conceptually, a lot like Wi-Fi, but for power. So chargers today are predominantly limited to things like cables and connections that can be very cumbersome and subject to wear and tear. They could have durability and reliability challenges, and they could limit certain product features from being introduced, like autonomous forklifts or vehicle interior cabins that could become package pickup delivery vehicles. So wireless charging almost today is a little bit like an oxymoron because it's predominantly limited to things like charging devices, where you have to place your device on a very fixed and precise alignment to the charging pad. These challenges are even compounded more on the lunar surface because the lunar regolith is very angular, it's abrasive, it's electrostatic, so it sticks everywhere, and it's a very strong insulator. So you can imagine here on Earth, you unplug something from your outlet and you plug it back in again, no problem. But on the lunar surface, the regolith could accumulate within the terminals of the connectors, fully insulate it, and then you'll have trouble plugging back in your devices again. So it's a major challenge to create reliable and sustainable infrastructure on the lunar surface. So we're here to fix that. We're developing the first wireless power platform that's universal. So you could think about it as a universal wireless charger across multiple applications and industries, from powering devices like power tools to robots to AMRs and so forth, that could operate from watts to kilowatts safely. And you could also do that in the most extreme and robust terrain. So since the creation of that video, we actually were selected for another 3 contracts with NASA, one of which is a phase 3 commercialization contract to prepare the system for upcoming Moon and Mars missions. So we're actually being evaluated this October for a total of around $2.9 million over the past year alone. For a variety of different solutions, from power interfacing solutions for infrastructure, to powering rovers at a distance from landers, to lunar terrain vehicles, and also having vehicle-to-vehicle charging systems, where an astronaut could actually power one of their lunar terrain vehicles to another lunar terrain vehicle. So we're actually starting our first Series A, or raising a $7 million round, so that way we could deploy our wireless power platform across all these different industry sectors, with today focusing on space. So if you're interested, love to discuss, and thank you all very much for your time. Forgot about questions. Yes.
Is there any loss in power during transmission?
Yes, of course. So I guess the amount of power loss depends on the kind of product, right? So to give you some examples, with NASA, we delivered them a power interface for let's say, cabling solutions for infrastructure at above 95% efficiency. We also delivered to them for powering, let's say, a rover at a distance of up to about a half a meter to about 80% efficiency.
Okay, thank you.
Yeah, no problem.
Hi, Caitlin Duffy Ryan, Machine Consulting. I'm curious if you've collaborated at all with Bell Labs on their 4G network setup that's happening on the lunar surface right now?
No, but I would be interested in doing so.
Okay, good to know. Thank you.
Hey, Josh, Rory here. Congratulations on your contracts. I saw on the slide it mentioned transmission lines. Now, you wouldn't actually be doing the line work. You'd be doing the power source, or are you involved in the lines as well? And this is on the lunar surface, just to to be
Yeah,
sure.
yeah. So you could think about us as like energy distribution. So we are actually doing like their cables as well. So that's part of our big delivery this year, where you can think about it as like conceptually like a toothbrush, where you put your toothbrush on the charger and you're able to charge your toothbrush. We're doing that for power transmission cabling. And we're working on not just the wireless side, but also the cable itself. It's due in October, yeah, this year. So it's been busy.
For the original charging, what is the source of the power? Is it what type of fuel, or is it a battery that has to get refueled somehow?
Yes, so we would have to interface with the source that NASA wants us to. For example, they normally operate at like 120 volt buses. So we've been tasked to interface with, let's say, the batteries of their lunar terrain vehicles, for example.
Is it a point-to-point technology or an area effect? So in other words, do you have to point something at the device, or is it just anything within a certain distance?
Yeah, at the end of the day, we're sending out magnetic fields safely, so there is directionality to it. That being said, you could think about what we try to do is often like a charging bubble. And based on how the devices are expected to be used, we could reshape and craft that bubble. So I guess a more applicable example would be automotive interiors to get rid of cables between the seat and the floor of the vehicle. No matter how you move the seat and even what kind of functions you use with the seat, we have to adapt to that environment in real time. Sure. Oh.
Where are we going?
Is the technology that you're using currently on the moon the same technology that you would use on other planets or other places that they would launch a rocket and land on? Or would that have to be adapted and changed?
There are different specs that we have to follow for the program managers for Mars versus the moon, for example. Yes, there are different requirements, so to speak.
So if you were asked to go to Iran by our president, it would be different.
A little bit.
Well, hi. Thank you for such a wonderful presentation. This wireless charging technology has been here for a very long time. I think Nikola Tesla has been there. But what is the X factor that you cracked here?
Yeah, I mean, it's been around since, at least like what we do, resonant induction, since 1893. I would say with us, the things that we do that are a little bit different are we focus on very high intrinsic quality coils or very efficient coils to extend that charging distance. To give you some comparison, the barometer that you use to compare one coil to another, it's called the intrinsic quality factor. It's a dimensionless parameter, energy stored over energy dissipated. The Q factors of coils today are usually between 50 to 100. What we've delivered for NASA, for example, could be between 500 and 1,000. So it's an order of magnitude more efficient, so you can extend that charging range. However, that alone is not enough. The other thing that we really focus and pride ourselves in is dynamic impedance matching and controls. So we could adjust in real time or kind of reshape and craft that bubble depending on how the products are being used.
Well, just a follow-up question on that. I'm sure a lot of people are curious on this part. What is the distance, like the proximity between the charging source and the sink of the energy? That is one part. And the second part is if anyone asks if that is within a cable distance, what is the difference to that? I'm just a curious electrical engineer. I have no intention to question it.
No, you're good. So I would say what we do is very product and application specific, but to give you some guidelines, usually vertically, the maximum distance that we do is up to about 0.5 meter to 1 meter. However, laterally, that can be very different. We've delivered successfully laterally over 5 feet to cover the interior cabin of a car, for example, because the distance between the floor of the vehicle to your seat isn't vertically very far, but if you want to make a package pickup delivery vehicle, a passenger vehicle, you want to be able to charge everything within the car. So that in that case, it's a little bit different. So it's a little case-by-case specific, but that hopefully gives you some guidelines.
Thank you. Okay, up next we have Oscar Schwartz and Marcus Kumashi of GyroPlant. Please come up.
Great. Hi, I'm Oscar, and I'm with my co-founder Marcus. We're from GyroPlant. We're building reusable and tunable root zone architecture to grow plants in the most efficient way possible. And last week, we announced our successful microgravity validation with the US Space Force. And I just wanted to show that video to you now. So we were trying to do two things with this study. We wanted to see if we could use mechanical force alone to hold a plant across various gravitational regimes, and we absolutely did that. And we wanted to see if we could contain the water just in the root zone so it wouldn't escape up through into the shoot zone, and there was full water containment. So we're really pleased with those results. And how we get the mechanical force that holds the plant across its lifetime from germination through to harvest is it's down to the manufacture of GyroCup, which is our reusable component. So we manufacture it flat, and then we invert it to its final geometry, which is where we get the mechanical force. And this is part of our broader approach, which we're calling tunable root zone architecture, where we're able to cater for various different crop and system requirements. We're able to channel water directly to the roots, not through passive absorption, but through surface tension and capillary wicking. And we're also able to create the perfect environment for plant growth through material composition and surface finish. There's three levels of application that we're doing. Firstly, we're just simply replacing raw, bulk, imprecise material on Earth in vertical farms and greenhouses. And that's why we're selling our base model sort of at the bottom. We're selling this around the world at the moment. What we're doing next is we're adapting our design to the various different use cases, including space. And that includes building out the irrigation architecture so we could feed plant roots in the millimeters rather than sort of the reservoir approach. I don't know what the American is for milliliters. and thirdly, we're treating GyroCup, this is the next stage, as a platform technology where we're going to be applying biotechnology directly to the root zone. So if you work in biotech, plants, genetics, surface finishes, we'd like to speak with you. But how this started was in southeast England, in Marcus's shed, where we built our first system, and we had two constraints. Firstly, we didn't want any imports. We wanted every component to be reusable and self-sufficient. And secondly, we wanted to hold the plant upside down because of our spiral design. And as we were building out the system, we realized that vertical farms and greenhouses don't grow in soil because of the biological risk and the difficulty of containing soil. They grow in single-use grow media or substrate, which is essentially raw material that's repurposed to hold the plant as it grows. And they come with various different problems. Firstly, there's a limited supply. These are shipped internationally around the world, and it's getting more difficult to get hold of these materials. Secondly, they carry disease, and they can kill the plant that they're supposed to be holding. And thirdly, they break down materially and causing additional labor and system issues. And really, there's a fourth problem, is the missed opportunity of controlling the root zone. Every other element of a hydroponic system is optimized, except the root zone, the engine of the plant. And in space, they grow in single-use substrates too. So this is the plant pillow from Sierra Space, essentially a Kevlar bag filled with clay. And that just can't scale. Firstly, it's heavy, it's single-use, and it's really inefficient. You throw away the water, the roots, and the material as well. So that's where we're building towards, scalable lunar agriculture, and we've got the pathway to do it. We're looking for biotech technical partners as well as investors because we're raising our first round. Thanks so much.
This is super exciting. I'm wondering, is it purely based on the geometry of the
I'm not exactly sure what to call it, the cup, I suppose, that holds the seed as it's growing, that allows for better like water access? And if so, why has this been this is awesome, but this feels like a crazy thing for us to only be figuring out now about how to do hydroponics effectively?
Yeah, great question. So originally when we designed them, they were designed to hold a seed in a particular position where through the silicone structure, you would draw up water to that seed, but without oversaturating it. Depending on the crop you're growing, you want a different amount of moisture there, and that has to be totally controlled. This has been done by NASA before. We have grown in substrate-free environments. However, it's done in a way which is not scalable, and it's done in a way in which doesn't really control the exact amount of moisture you want for that seed. So our structures provide that very, very precise amount of moisture to take that seed all the way from germination to full growth.
Fascinating. Thank you.
What would happen if there is some kind of disaster in space? I see that you made it, not move when it was shaking around a little bit, but how much trauma could a system like this withstand?
Yeah, great question. So this is relevant for our terrestrial applications as well, because we've actually installed our technology on moving systems on Earth, which basically move from horizontal to vertical, back to horizontal again, thrown around and spun around sometimes. And it all contains, the plant is most of the time healthy. It depends on the crop. Some plants are just very susceptible to things like root shock. However, most of the crops that we've grown can be controlled in a way where the legs of our design hold those roots in a very steady position.
Hi. Just back here. Right here, on the right. Quick question. So are the design specs of the equipment or the device any different on the conditions that you see on Earth, and so if you do it for space, or the mission profile is lunar, would you have to design it differently for any other atmosphere, maybe Mars or anything else? Like, what are the factors that you take into effect while designing the actual device?
Right. So I think there will be different cups depending on the environment and the different types of gravity fields. So we designed a cup last year specifically for the parabolic flights, where we can go to different types of different forces around that cup. Right now, it's all designed for with the lunar base in mind. So we simulate those on different types of software, where you can simulate different types of gravity conditions. But the reality is, water and wicking action performs differently under any environment. So what we're working on now is design a versatile structure which you can tweak and you can change the things like the distance between legs to change the wicking action and the capillary forces that play. So a versatile cup is what's required in the future for different space environments, yes.
Any idea what increase in efficiency you have in terms of water usage or nutrient usage?
Right, so traditionally hydroponics is great because we can reduce water consumption on Earth by 95% plus. Generally, you fill up a trough full of water and you place a float on top and you allow your plant to grow. It's very water efficient on Earth. In space, what we can do, we can germinate a seed with less than 0.5 milliliters of water and provide the exact amount of moisture that seed needs without any waste water flowing around it, which isn't being utilized by the crop at all. So that's a further reduction by water by another sort of 95% on top of that. So it gets very precise very quickly.
But, with the current substrates on Earth, so coconut husk, for example, it absorbs 6 times its weight in water, and so you throw that out at harvest. So essentially that's a huge amount of water we save just without even testing it in lunar conditions. Yep.
If you come by, we can show you one of our designs where you can't even see the water that's essentially there. You have to look really closely. So drop by afterwards.
Okay. Please welcome Caitlin Suarez of Terra up next.
Hello. Okay, so we're going back to wireless power. We had a little break with the bio and the plants, back to energy. We're talking about a terawatts underground wireless power and data transmission. So I want to imagine for a second, you're coming to visit us at Terawatts. We'll be out in a beautiful field in Tennessee. We'll hand you a light bulb with a receiver on it, and then as you walk out in the field and you put that on the ground, the light bulb will turn on. I gave this pitch in DC, and afterwards some engineers from Lockheed Martin came up, and the one question that they asked me was, what about the moon? And so I said, yeah, what about the moon? And as it turns out, the first place that we're gonna be heading towards are these craters, and the goal is to get to the bottom and look for ice. And so these craters are constantly in shadow. They can't use solar panels or things like that to power the rovers or the robots going down there. And so wireless power is being called upon in order to get to the bottom of the crater. So power beaming is obviously in the cards, but we're asking the question, what if you could make the rocks themselves like a transmission wire? So your R2-D2 is going around and it's being powered the whole way as it rolls along the rocks. So this is our vision for the future of the moon and one day to Mars. You'll be able to deliver power and data underground. We are using conduction currents through the Earth, and so you can drop a transmitter, you turn it on, it makes a field, and then you put that receiver to pick it up, or you can do some fun bits to the wheels of the robots to get them moving along. We have a prototype in Tennessee, so that's the light bulb with the receiver on it. We're moving power about 10 watts over 50 meters at 10% efficiency. And some of this sounds like truly the works of sci-fi, but we are combining two well-known fields of science. The first is electrical engineering, and the second is electromagnetic geophysics. And so it's known today that electric currents are moving through the ground, and we can use those to make maps of the subsurface. And so in tweaking that natural phenomena of electric currents through the ground, we can use this as a power delivery mechanism. The team is myself, as a full-time employee, and my co-founder is Dr. Charles Van Est. He's the professor at Tennessee Tech University. We have advisors ranging from mining to space to defense. Dr. Kwan is the Lockheed Martin scientist that I mentioned before and has gotten us into the headspace of space. We've been rolling through primarily with NSF funding so far. We've got a few pending NASA grants, so fingers crossed all things work out there. I'll just kind of mention, just to reemphasize, you all are getting a physics lessons today, but there's the air-based wireless power, as we saw in the first presentation, and we're working stuff that's completely underground, so it's a little bit different, but same end goal. We're currently looking at our pre-seed, so about 1.6 million if you're interested in investing, and with that we'll hopefully be hiring our first employees. The first market is going to be in mining. We're thinking about how can we move this very slowly, so sensors in giant piles of rocks for mining, and then moving towards defense and space applications. So please get in touch, and if you're an electrical engineer and you want a job one day, let me know. Thank you.
Hi. One of the slides you mentioned with over a kilometer and 80% efficiency, what needs to be true for you guys to hit that?
Yeah, the key technical risk that we're putting all the money from the grants towards is if I can increase the surface area of the transmitter and then build a receiver that looks identical to that, we have some hypotheses that you're going to get those 2 points to start connecting, and it'll be directional as opposed to omnidirectional. So we have some new tests coming up, and hopefully that'll help sort of solidify that question.
Okay, so dig deep and point them against each other?
Well, you'll dig deep, you'll have 2 matching, and then you kind of get some of the
magnetic fields involved, and they'll start going, instead of in any direction, it'll feel a pull in one direction.
Channel in, okay. Thank you.
I have a question. While designing the electrical system, how do you deal with coupling or eddy currents, which might form in several sub-meters under the ground?
We primarily are doing that right now by having the transmitter be vertical, and so instead of having it sitting horizontal at the surface where it's more likely to get sort of stuck in the eddy currents, we're forcing it from top to bottom to get the field propagating through any imbalance. And I'll say that by chance and luck, we're in Tennessee, which is completely limestone, so right now we don't have too much data points on variable bedrock.
Hey, I was wondering if you looked into how the underground geometry affects the transmission, and I'm asking that very specifically towards like the mining applications where they're actively changing the underground geometry where you might want to transmit power.
Yeah, so I'm cheating on mining, and they put one specific rock on a giant pile, and so I'm gonna get power through that first. Because the question is, how will we adjust for heterogeneous bedrock? Part of what we're thinking through is you'd adjust the receiver orientation, so they might have to be longer or shorter. And then we've also got some ideas towards like the first question, if I can get those magnetic fields to couple, I actually might be able to get the system to like relay it, so it'll kind of go through, hit a relay point, and then retransmit it in like the frequencies I need it for that rock type.
I have a question. How much does your technology depend on the type of rocks?
Yeah.
The area where you're based?
The electromagnetic geophysicists categorize general Earth into 3 categories. So there's conductive rocks that are red, there's blue rocks that are blue, we call those bluites and redites, and then there's green, which is like an Earth average. So the system primarily needs to be able to be characterized in those 3 types, and you'll be able to manipulate most of the Earth's surface / the moon.
Hi, thank you so much. Well, I have a very basic question. The thing is that Earth return, or for I think more than 50 years, people used to have HVDC transmissions, and part of it, the neutral used to be circulating through the ground. And somehow people realized that nearly 30, 35 years later, that it's better to build a full-time return path through the conducting wires, through the HVDC. So it's not just about the loss of the power through the ground, irrespective of that. The thing is that it distorts the power shape, because at the end of the day, the end user wants that his power quality has to meet certain standards. How do you really reflect upon that?
Yeah, that's a good question. We put an AC current through the ground, and so one thought is you could put the AC current through and then collect it in a battery, and then pull from the battery in whatever form you want it to be with like a rectifier. So you can manipulate it to get it where you need it to be.
So the question is that if people go for AC, like some of the other persons have asked, that there is a question of eddy currents. So either you have to have a trade-off between the DC or the AC, because losses both sides, you should find an optimum. I think that's quite evident in that.
Yes, that sounds great. Have a chat afterwards.
Sure, thank you.
All right. Up next, we have Devin Nathan from the Defense Entrepreneurs Forum.
Thank you so much, Malcolm, and thank you to Doug and the New York Tech Alliance for putting this on. Greatly appreciate it. I'm Devin Nathan. I'm the co-lead of the Defense Entrepreneurs Forum, New York City Agora. Defense Entrepreneurs Forum, we like to say DEF. So DEF is dedicated to connecting and empowering individuals in the national security community. We're a nonprofit organization made up of an all-volunteer team. We're here to help mobilize informal networks as a strategic capabilities. So through our events, partnerships, and initiatives, we strive to foster a culture of collaboration. We have agoras in DC, Colorado, and here in New York City, and we regularly host events for the community, so go please check out our website. If you or anyone you know is interested in the national security ecosystem, you can find us at the booth in the back, and we'd love to connect after this. So with that, I have the honor of introducing the next 3 people to demo. I'd like to call up Dan Rapoport of Dan Rapoport Design.
Thank you, Devin. Much appreciated. So hi, I'm Dan, eponymously, and is that going? Yeah. So what I'd like to talk to you about tonight is human-guided machine-stabilized construction 3D printing, or at least an aid to that. So the idea here, well, actually, so a little bit about me. I have a background in architecture, transplant. My job is basically to think about all the design decisions that could go wrong, and then don't make them right. Make sure the engineers don't. So with this project, I've got funding from the NASA Rhode Island Space Grant, a little bit from NASA itself. So the crux of it is, in last 6 years, costs of construction on Earth rose 31%, and 1.2 million people left the industry, which is crazy. Things are changing in a big way. Construction 3D printing has kind of risen up to take on that issue, but it's imperfect, and it's massive. So the claim savings are great, claim time savings, labor savings, cost, but as you can see, it requires massive gantry systems, long setup time, complex interfaces, and operators who need to be trained for months and months. So we can make it more than just a novelty. Why not? How could we do that, potentially? If it could be human-guided, if we could keep people in the loop. So the idea here is to create something that's quick to set up, that's accurate, easy, mobile, and works independently. So no massive positioning system. So sorry about that. Weird image. But what if we could make something that was had a low barrier to entry? So I took this to a lot of different people, but one of the most interesting, I think, was Michael Fisk, who works for Jacobs, but will essentially be the person in charge of making the decision for what is going to be built on the moon, and what structures will be built, and who will build them. And he thinks it could be a great repair tool, and I think he's right, because instead of having a massive gantry in space, we have something that's much more size and cost efficient. Also talked to a bunch of really interesting people. Maybe some of you recognize the companies, but great people, great conversations. So the concept is this, that we have a small device that is, it can know its own position in space, doesn't need a gantry, and I looked into ways to do that, but at the end of the day, you need to be really efficient with an astronaut's time. You need to make sure that $130,000 per hour doesn't go to waste. So where do we start? Lots of testing. Weight mobility, extrusion, more extrusion, materials, and then eventually the most important thing is local positioning system. So how do we get this thing to know where it is in space? It's called inside-out computer vision, which is the same thing that is used in Oculuses, and actually that's what I've got at the back table if you want to come check it out. But so using that, you can identify where geometry is and then have a print head that locates itself towards it. Just a fun test. But here's my control system. It's a lot, but it gets the job done. And so this is what it looks like. Basically, this device orients itself towards 3D architecture in space, can move towards it, and the idea is eventually deposit cementitious material, either lunar regolith combined with sulfur or Martian dust combined with sulfur to create a liquid and then create a very, very strong solid. So locating itself in space, can do. Now, we need, well, there was supposed to be a live demo. Apologies. Should have taken that slide out. But things are getting much better. Technology is miniaturizing. We can run AI on tiny chips. So moving forward, how can we develop this in the future? Put it on the end of a rover and and use it as a detachable tool. You know, if something breaks, we need to be able to deal with it in space. On Earth, we have gantries that we can fix. In space, we can't. So we need basically a repair tool, and this is that tool. Thank you. Any questions?
So this is intended for human use, scalable, mobile. In a scenario, what if the astronaut were to sneeze or just move around or extrude a little extra? How do you go back? How do you?
Yeah,
yeah,
that's a great question. So long story short, it does most of the work for you. So it orients the extrusion head. So if the astronaut moves it, you know, imagine like a chicken's head in space when you move the body. Yeah, gyroscopically aware.
Do you have any videos of that working three-dimensionally to create a wall or something so we could see what it does?
So that's what I got right now, unfortunately, and it's being a little touchy as well. There's going to be a live demo today, but unfortunately there's not. But it does do that. So it doesn't actually extrude material, I should be clear. The idea is that you would connect it to a pressured system that would push material through it. This is just a prototype that is more focusing on the location portion.
Hi. What's to stop you from using this on Earth?
Nothing. That was actually the original idea. I just happened to talk to a lot of people, like the last presenter, who thought it'd be a great idea for space. So, yeah, if we could avoid massive gantries here on Earth, that would be great. Thanks.
So, would you have an accompanying software model to have like every part that might be on a lunar module that could conceivably break? So then you just have to kind of enter that into your model and it could print that for repairs?
Yeah, well, I think that's actually already being done with smaller scale 3D printers. This is for you know, kind of a larger scale construction thinking.
Fair to say it's kind of almost like, thank you, a steady cam for 3D printing?
Yeah, more or less. But the difference here is that it's using computer vision to do it. So you actually, like the hardware is very simple. So it's kind of like live photogrammetry to identify where it is, supposedly accurate within the millimeter, and it's not something that's being utilized right now.
Hi, so what is it about this that makes it inherently human-centered? Why is it that this cannot become an AI-powered product or device down the line?
Yeah, it totally could be, but I think the fact of the matter is that things break, systems aren't perfect, and at some point you'll need a human in the loop, especially for something that's this consequential. And you know, my day job is I design transplant equipment. And you know, if something goes wrong there, that's very, very bad, right? You know, it can mean someone's life is on the line. So here you want to make sure that a person is involved at all points of construction, because unlike Earth, if there's a break, if there's a leak, it's life or death. Cool. Thank you.
Thank you so much, Dan. Next up, I'd like to introduce Hari Mahesh of Melegen Labs.
What's up, guys? How are you guys doing? Good? Okay. Before we start the presentation, gotta ask some questions to make sure I know my audience. Who's working in aerospace right now? Anybody working in an aerospace company? Okay. Okay. Who wants to work in aerospace? Hopefully a lot more. Okay. And this is the question that usually there hasn't been a hand raised. Anybody been to space? Okay, cool. That confirms it. Anybody want to go to space? Yes, excellent. I do too. And the biggest problem that's going to stop us from going to space as humans is space radiation. And that's what we're looking to solve. So before that, before humans and biological systems can get to space, space is becoming densely populated with electronics. 12,000 satellites are launching, right? 100,000 satellites are projected to be launched by 2030. And we're going to have $15 billion in orbital compute in that time, along with $50 billion spent by just our government for national security. However, space radiation is that single greatest threat that is going to stop not just humans, but also electronics from interplanetary exploration and a thriving space economy. 38% of all failures are attributed to space radiation. 500K is the average cost for rad-hardened electronics that are honestly just outdated. And for humans, and this is where it's relevant, being in space causes 10,000x increase in cancer. So current rate protection to that point is a lose-lose situation, specifically focused on electronics. You either have to use heavy aluminum or you're using archaic rad-hardened electronics. And that's why we've developed MLC1. So MLC1 is our proprietary hydrogen-rich polymer biomaterial composite that we've developed all fully in-house, where the goal is freedom. And freedom to buy any off-the-shelf commercial processor unit, shield it with our material, and be able to take it into space. So what that looks like, our material is 3x lighter, 3 times more effective, extends lifespan by 7 years, along with 10x fewer bit flips for commercial off-the-shelf units compared to aluminum, which is what's used today. And so one of our companies that we work with, one of our customers, was able to replace this old processor unit with a off-the-shelf unit just shielded by our material, and it essentially represents a 60% cost savings, but also pretty much a 20x in output. And so we've tested MLC on the ground, and we're actually going to space 3 times this year, which is a soft launch because we announced one of the missions last week, and we're announcing the next mission now. So we're on Transporter 17, we're on Transporter 18, and we're going to go to the International Space Station. And our specific goal with the International Space Station is to validate orbital data centers. And so our mission is going to generate the first AI processor data set that is shielded by advanced radiation shielding. So to that point, there's a lot of value here in terms of how much revenue, sorry, I'm speeding through given the time. But the realization is not just shielding, but the entire industry is stuck in the past. So a lot of different issues in terms of backlog and capacity. And so to that point, not just the material, we're building the world's full stack radiation ecosystem. And so when you look at the ecosystem, there's 5 different levels that are needed to solve, and we're building a product and service offering across all of that. And that's all going to be fully live by Q1 of 2027. And the key things to call out is our AI-powered radiation analysis platform that we built in-house using advanced physics engines and simulation models that we were using and we're exposing out for customers to use. And soft launching it here in New York. We're a New York-based company, but we're going to be opening our first radiation testing facility in Texas next year. So that'll be the first aerospace hub for environmental testing in the country, available for specifically aerospace companies. And this is a master slide of exactly where we're going. What we need help with right now is, of course, we need more people interested in the aerospace industry. We hire, of course, people in radiation science, but also in electronic engineering, hardware engineering. And we're also looking for any investors. We aren't raising right now, but we will be in the future. And then last but not least, if you need radiation shielding, come find us. We think of this as the phone cases for your electronics, and that's what we're looking to sell. This is the team and our investors and backers. And yeah, with that, thank you so much. Excited. Cool. I think mics are going on.
Hi. So will this technology be applicable to satellites that are already in space, or is something that's going to be launched in the future?
Yeah, absolutely. So this is like a specific like material So we're going to be launching in space right now on these missions, but the idea would be it's for future missions that you're launching. If there are a lot of companies working on replacements, right, for satellites existing. So if you're going to put new payloads up there, you could use our shielding material in it.
Will that also work in spacesuits or just the satellite material?
Yes, but we are not we haven't validated that yet. We've done some internal testing, but we're specifically focused on modern electronics. So think your NVIDIA Jetson Nanos, any off-the-shelf processor unit. You could, like, literally this means that you could take your iPhone, put it into a satellite, it could last for 10 years. I really mean it when I say it's a phone cover for space.
So have you looked into any applications for clothing and potential protective usage on Earth, for, cleaning up radioactive spills or any sort of issues environmentally?
Yeah, absolutely. We are already working with some medical partners and nuclear partners as well for both protective material, but also for their shielding purposes, either infrastructure-wise. So that's definitely a possibility. Again, we come from an aerospace and a commercial background, but we're talking to national security and government stakeholders right now. So definitely a possibility and definitely something we want to use. What we're gonna sell this summer ideally is hats made of our material that you can wear, which is necessary for commercial flights because there's a lot of radiation risk when you fly commercial.
Hey, Harry.
Yes.
Right here.
Sorry, I don't know. Right here. Oh, yes. What's up?
So from my understanding, this helps with like the cumulative radiation damage over time.
Yes.
But what about those one-off single events that would cause those bit flips? Have you guys validated, tested, like what are the upper thresholds of the technology that you have?
Yeah, absolutely. That's specific, a great point. So to dig into that deeper level, aluminum, what you find for specifically advanced technologies, so advanced computing, is that it's bad from two parts. One is secondary radiation, which is outgassing, and then also the degradation, which then allows in single upset events and other things. So that's what we're specifically optimizing for. So one, we have very low outgassing. We're already NASA certified. We've done that testing. And two, that's what, I can't go into the exact details of our material. We use, yeah, I'm trying to see how far I can say without, yeah, it's a few different layers that then like bounce off of each other. Yeah, that's as much as I can say. Yeah, sorry guys. Sorry, just to answer your question, exactly that. So if you guys know the Belgian election results, yeah, we would be able to protect against that on Earth as well.
To play the devil's advocate briefly, you're comparing here to aluminum a lot, which has been fantastic for structures in space for a myriad of reasons, but to my understanding is also kind of uniquely bad from a radiation perspective. Say if just sort of randomly there were to be a launch vehicle that was expected to drop the cost to launch dramatically, and maybe there was would like other materials potentially be easier to use if they were slightly heavier in space that then maybe wouldn't have as much of a radiation challenge?
Yeah, that's totally fair question. And he's also building a spacesuit, so hopefully we're going to work together in the future. But point being, to that point, what we're starting with is a lot of CubeSats as well. So that's where it's not just a weight concern, it's also space, right? In terms of like how much space you have available. So what we found, there are competitors potentially, or people who've tried to do this before. The hardest part of this has been they just haven't delivered, right? Like it hasn't been able to withstand. The one key thing is we're not replacing aluminum or any metals in terms of structural integrity, right? We're not trying to be the structure, so that still may be aluminum or some other form of material. We're specifically optimized around shielding. So it would be a layer either in the coating, the panels, or we could be specifically for the processor unit, so just like phone cover, like I said, but like for the processor unit. But then the other piece is we can do dot coating. So if there's a specific part of a processor or an electronic unit that you needed to cover, we could do that through conformal coating. So that you can't do through metals. Yeah. So that's specific. Yeah.
Awesome. Well, thank you so much, Ari. Appreciate it. Like him, Dan, they have their booths in the back if you have more questions and want to ask them after this. So next up, I would like to introduce Ian Fichtenbaum from SpaceRig.
Hey everyone, good evening, thanks for coming. My name's Ian Fichtenbaum. I'm a space entrepreneur and former space entrepreneur and also space entrepreneur, and I've had the pleasure of leading up a number of space manufacturing. And you know, with space growing the way it is, the biggest challenge is keeping up, matching the pace of launches. So SpaceRig is about mobile infrastructure for responsive space. So what does that mean? Problem, space is moving faster than ever, but infrastructure hasn't kept up. Equipment for building and testing for space is either legacy or it's limited, it's bottlenecking. It takes too long to get for some companies, it's difficult to use, and it's expensive. It's capital expenditure. The solution from our perspective, modular ground infrastructure. What does that mean? Well, from the SpaceRig point of view, we wanted to tackle a particular problem. And this particular problem first was just fueling. It took too long for certain kinds of fuels to put it on into a satellite to go to space. So we built a fueling system. And so I'm going to show you, we built it for the US Space Force. And you're going to hear Adam.
So in about 2 hours, we had it unpacked and set up, everything connected, ready to go. We came in the next morning and we actually performed 3 fuel and offload, rehearsals on Tuesday. So in about an 8-hour period, we performed that 3 times. And today, we're going to do this demo for everyone, where we're going to fuel this spacecraft tank behind me. And at the end of the day today, we're going to pack it all up and ship it out of here, and we're going to do it in about 2 hours. So our goal is to get that timeline down to as rapid as possible.
The next thing we did, solving another problem, was testing. Testing is a critical part of building any space system, and the test equipment out there is expensive to get, and it's complicated to use, and it takes a while to get. So instead of sending our systems to a test rig, we decided to build a mobile test rig. And here's Michael, the space rig.
Piece of infrastructure that we ended up making was this mobile TVAC unit. Basically, it's everything that a typical client would expect to see in a normal lab, except now it's mobile. Great idea. You've made your shiny box that's going to go into space. You want to make sure it's going to work when it gets there, and you'll put it into this chamber to simulate that environment of space. So it's a 4 foot by 4 foot thermal vacuum chamber that's cryogenically cooled, heated, so it can go as cool as you like. You know, gas nitrogen, which is minus 160, and then as hot as you're really willing to go. You know, plus 20 or so. Variable ramp rates depending on what you want, and reconfigurable.
What's our next vision? Now that we've tackled testing and fueling, assembly and manufacturing. This is our vision for the space starter kit in a box. Has the workspaces, the small test equipment, the quality control, the AI-enabled design and assembly that can come in a modular system, in a trailer that can come to any company. And our vision is that any company can rapidly become a space company. They have the right infrastructure. The SpaceRig team, we come from across the space industry. We have support from the Space Force and a bunch of other great organizations. And we're raising a pre-seed of 900K, recruiting and looking for technical partners. And before you clap, I also wanted to say we're also doing deals with the companies in this very room, and I wanted to announce, where's Hurry? We are announcing that Melegen Labs will be hosting our our mobile TVAC unit, a $1.6 million deal, and we just had the ink dry on that deal today, this morning.
This morning, so excited.
Thank you.
Yeah, of course. This is going to be in the Texas facility that we showed you guys earlier, so I didn't want to break the news. That's why I said environmental testing, but let Ian do it.
Yeah, environmental testing, TVAC, and radiation, and hopefully other systems.
We can open up for any questions. I think there might be one in the back there.
There we go. Can you hear me? Okay, awesome. So I know that you have in the past looked at potentially doing personal spacecraft as well. Is this the development from seeing how many issues were facing that initial idea and solving for the problems that you came up with or that you discovered upon that investigation?
Yes, this came out of the desire from some companies and some government agencies to move things through the system as fast as possible, including, and that included not just the ground infrastructure, but the design of the satellites. So that's part of our plan, but it's not, we haven't built that part out yet because we've just been getting more traction on the ground infrastructure.
All right, thank you so much, Ian. We greatly appreciate it. Next, I'd like to introduce Evan Lerner from Empire Space.
Testing. Great. Yeah. Hey, everyone. It's awesome to be here at Civic Hall at a space event. I remember coming by to tour this space maybe a few months ago with Doug. Like an incredible space in New York, and I think the first space event they've ever done, so this is super exciting. Also, like, I guess thanks to Doug, thanks to Civic Hall, New York Tech Alliance, and everyone else that put this together. So just very excited to be here. Yeah, I'm Evan Lerner. I'm a co-founder, and I run Empire Space. We're a 501c3 nonprofit. We're focused on growing the space industry here in New York. That covers all of New York State. But that does also include New York City, obviously. We do a bunch of different things. We started around 5 years ago. We built out what we call today the census. It's a database of all of the stakeholders doing anything in space in New York. So we're at over 1,500 entries today. This includes like space companies, like SpaceRig, who just talked, as well as I think everyone else that's talked in the room. Also investors, like academic programs, student groups, civic groups, et cetera, everyone. And then we also map all of that up to legislators, and then we help advocate for the space stakeholders in New York with those legislators. We do many other things as well. We do analysis, we write reports about all of this data and all of the people doing space in New York. We host events. Obviously, there's this event today that we're co-hosting. It's very exciting, but we also do other things throughout the year. We have about one thing each month. Our big event each year is Space Week New York. That's in April this year. That'll be from April 20th to 26th. The biggest part of that will be on April 24th on the Intrepid Museum, which is very exciting. It'll be like a full day of programming. So if you want to learn more about that, you can go to spaceweekny.com. Also, if you want to learn more about Empire Space, empirespace.org. We have our data, the whole census, that's on our website. So you can check out all of the different companies and everyone doing things here. And there's more events coming as well, as Walter said at the very beginning. Uplink, the Space Business Summit, that will be in the fall, and there's a lot more. So if you want to learn more about events, other things happening in New York, feel free to come to me or reach us, info@empirespace.org. Yeah, so I'll pass it off to the next one. We have Owen at Starsuit. I mean, he'll tell you about it, but they're making fabrics for spacesuits.
Hi, everyone. My name's Owen Zoit. I run a company called Starsuit. We make skin-tight mechanical counterpressure spacesuits. So, what's that mean? So, a spacesuit fundamentally has to do three things. It has to provide you from protection from thermal factors and micrometeorites. It has to give you gas to breathe, and it has to provide counterpressure in against your body. So here close to sea level, we're experiencing 14 pounds per square inch, 40.7, pushing in on us from all sides. Current spacesuits have a person-shaped balloon that's inflated to 1/3 of an atmosphere of pure oxygen, and then has all of these elaborate constraint layers over the top of that to stop you from kind of getting stuck like the Michelin Man. But it is fundamentally like being inside of a bike tire. That breathing bladder is combining both breathing and compression, but it turns out that your body really doesn't care where that compression source is coming from. And if you can separate out breathing from compression, you can do both much more simply. So we work on mechanical counterpressure, which is kind of a sidestepping of all of those problems by making a textile, which you can see here, which is applying pressure directly to my skin based off of a 3D scan we took. This is a fully 3D printed kind of chainmail-like fabric, which prevents my body from expanding in a vacuum environment. As you can see, this glove is porous, which is probably going to freak a lot of people out when I say this is a spacesuit. Your skin is actually fine with like relatively small areas of exposed skin. And because all of those links are able to slide over each other, we have quite good mobility. And this actually works. So this is my hand in a vacuum chamber down at 98% of pure vacuum, which is well below the point where you would have enormous nerve and tissue damage if I was not wearing this glove. Performing a dexterous task here of transferring very small nuts between bolts under vacuum. This is something that you could never dream of doing in a gas bladder suit. You just do not have the dexterity. But this is a cool demo, but this is really not like what, if there's anything I want you to take away from today, is that gas bladder suits are just not up to the task of bringing humans deeper into space. The current suits that we use are, bad is not even like a, bad doesn't begin to explain it. Having a gas bladder system, it is not uncommon for astronauts to come out of EVAs with their fingernails falling off, covered in bruises, getting shoulder injuries. It is so bad for how, it's painful, it's expensive, incredibly expensive. Current spacesuits are expected to cost around like mid tens of millions of dollars per suit. The old Apollo suits and current EMU suits probably in the more $100 million range. But this is the weak link of human spaceflight. This is, as we try to go out and do more and commercialize the resources of the asteroid belt and do anything else that we want to do with humans in space, suits are going to hold us back until we can unlock mechanical counterpressure, which we have done here with just 2 people over the last 3 years. This is something that people have speculated on for a very long time. We've actually been able to deliver on that. So I want to chat with more engineers with experience in developing human-rated systems. We've specialized really hard in the fabrics for making this. There's a lot more that goes into spacesuits, as you might imagine. Additionally, we want to chat with more investors that share our vision for human expansion into space. Would love to open the floor up for questions, as well as shoot me an email. We also have a couple of textile demos over at a table. If you'd like to feel what they feel like, it's a pretty fun material. Thank you.
Hi, quick question. Don't you have to retain also moisture in addition to pressure? Because you said that the skin is fine with a little exposure.
Yeah.
How do you deal with moisture loss?
So that's a really good question. It turns out that actually that totally works in our favor.
Most of the problems, so current spacesuits have these elaborate liquid cooling garments that run all throughout the suit to try to keep the astronaut cool enough. Of course, there's all of the energy from the sun, which we're pretty good at mitigating through layers of mylar. But of course, the body is also still generating all of that heat. And so what we can do is just allow, and what researchers were doing when they started on MCP in the 60s, is they just let the astronauts sweat through the layers. And the evaporation on the skin cools them down. So that actually works for us. And it's been neat to experience while I was in the vacuum chamber. As you go down through about like 1 PSI, absolute, that's where all of the moisture on your skin sublimates, and so you get really cold all of a sudden. But then as you sort of move around, then you warm right back up. So, great question.
Hey, this looks really cool. Thank you for sharing this. In the case of breakages, would something like an elastic patch actually be able to hold any broken links together well enough, or is that just not something you've looked into yet?
Certainly. You'd certainly be able to repair it. It's the kind of thing where, I mean, there's different gaps across the suit, all of which are, we found, below the range where any sort of embolisms or any sort of low pressure zone inside the body would start to create a problem. It's not the kind of thing that you would want to keep running the suit with, like if you had a break, but it's go back inside the capsule, stitch it back up, and you're ready to go. Unlike current suits, which right now is repairability is a nightmare, and is only going to get worse as we go to the moon and Mars.
How does it defend the astronaut from radiation? It's a great presentation. I just was wondering, when you typically go to the outer space regions, radiation is one of the biggest concerns. And also, traditional astronaut suits also have a way to recycle the bodily fluids and store them and then filter them out. So how does this incorporate that?
Both really good questions. So radiation in space is absolutely an enormous problem, really big for electronics, and will be really large for long-term human habitation. Most of that is going to be minimizing time that you spend outside. Of course, we can add radiation shielding layers into this with Melegen and all of that. But also, it's like, if we get to a point where more astronauts are dying of, far future astronauts are dying of cancer than anything else about operating in a super difficult to live environment, we're probably in pretty good shape. And then around water recycling, it's a little bit of an oxymoron. Current suits actually don't recycle that much water. The way that we cool suits on the EMU, and I think also on the Orlan, which are both the American and Russian suits we use on the ISS, they spray water out into space. They concentrate all of that water from the liquid cooling garment and that is captured in the breath. And they concentrate it and spray that warm water out into space just so they can get it away from the astronaut, because it's so hard to get rid of heat in a vacuum.
Hello. Great presentation. But when you're going to, let's say, the moon or Mars, is this going to protect from dust? Because I remembered reading the dust can shred your skin.
Oh my God, yeah. The regolith on the moon is gnarly stuff. So this would be integrated with a suit port architecture, like traditional, or like all of the spacesuit models that are currently being developed. This would be a layer you wear underneath a dust and thermal mitigation layer, which would go outside. So this really replaces the bladder, which is all of the bulk. And instead of integrating that bladder in with the rest of the suit, like you'd see in the current any of the AX IMU or EMU prototypes, this would have two separate systems where you'd have a dust and thermal mitigation layer and then a skin-tight mechanical counterpressure layer that stays on the person as they kind of slide into the spacesuit from the back.
Great, thank you.
Of course.
Sorry, based on are the spacesuits materials going to be different for astronauts, in the moon and on Mars? Because the atmospheres are very different on planets.
Yeah, that's a really good question. Getting rid of heat on Mars is uniquely hard because it has just enough of an atmosphere where convection starts to be a viable heat transfer method. But unlike on the moon, where it's basically only radiative, and so that's how a lot of thermal insulation systems in space work now is with layers of stacked mylar to only ensure there's radiative heat transfer between the layers. On Mars, that's going to be a lot harder because a little bit of that carbon dioxide atmosphere can get in between and allow for more, for easier thermal transfer. We're going to have to get smart about how we do thermal regulation on Mars for sure. That's going to be a hard problem.
Thank you. That was awesome. We were supposed to have Icarus Robotics with us. They were not able to come today, but we do have a video from them. I guess to give their one-liner, they're building the robotic labor force for space, but they'll probably say a lot more than that in the video.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
My name is Ethan Brajas, and I'm the co-founder and CEO of Icarus Robotics.
I'm Jamie Palmer, and I'm a co-founder and CTO of Icarus Robotics.
I was lucky enough to find engineering, and one teacher in specific in my high school, when I was 17, was able to introduce me to NASA. You're a teenager, and you're working on something, real spaceflight hardware, that's going to the space station, and you're understanding everything that goes into that. I think from that moment, I was hooked. And I was lucky enough to be picked up by an accelerator called Entrepreneur First. And that's where I met my co-founder, and Icarus was born. And we're building the robotic labor force for space because of how hard it was while I was at NASA to actually have astronauts do things and actually implement things and build things in orbit.
At this time, I was obsessed with the idea of not only human-robot teaming, but general-purpose robotics and what this actually means for the future of humanity. It's very, very obvious that I think humans aren't going to scale in the way that we need to in space. First of all, the economics. So it costs $130,000 an hour to keep a human alive in space. You have to roll in the cost of the life support systems to keep them alive, the consumables that need to go in to sustain them, and also the ground support team that needs to essentially quarterback them on the ground.
Humans that go to space, they want to be doing the thing that they trained years and years of their life for. That's pushing forward the things that could make a massive impact on Earth. And when you have robots that can take care of all of these menial tasks that they usually spend it on, whether that's cargo bag logistics, whether that's seal inspections, these are all things that they can now take that time and spend it on something important. And you can have humans in space for longer. But you don't get there without first automating a lot of those boring tasks. And so that's why we say with more robots in space, you can actually have more humans in space.
If we can take care of the things that take up 60 to 80% of astronauts' time, we can then immediately give back time to these astronauts such that they can spend it on what they've been trained for, what they're great at. So I think we're going to see an outsized number of robots in space. I think the demand is screaming for it. The demand for labor is calling for it.
We're seeing more and more applications in re-entry vehicles, in manufacturing at scale, putting data centers in orbit, building massive amounts of infrastructure. We want to be, in the long run, the labor force for space. That's the legacy that we're building towards. It will be one of the largest companies, if not the largest company, in the next 15 to 20 years.
Okay, big round of applause for everybody. You guys are amazing. Great work. So this is the part of the meetup where we'd like to invite all of you to come up and put your own ask out to the community. So we're going to devote 10 minutes tops, and we're going to set a timer. And the first folks who are in line and able to get in under the 10-minute mark can put their ask out there. You win. So, Jeff, you want to lead the way? Okay.
Hi, my name is Jeff Paul. I'm the founder of Zeotag. We're the AI video platform. We're a sponsor here at New York Tech Meetup. And what our product does is we take long format video, we make it fully accessible to everybody, including people with vision, hearing, and learning disabilities. And we also do analytics on the video. And for tonight's presentation, when we get the video, we'll do analytics on each presentation, and we'll give them to the presenters. We'll say, this is how you did. And it's one of the features of our product. If you have an interesting video project that you're interested in, please reach out to us. Thanks very much.
Hi everyone, my name is Alex. I'm working on electrical vertical takeoff and landing vehicle. At first, we will be focusing on ultralight category. Next step will be a flying taxi. So I hope this approach will allow us to move without any back and forth with investment. However, I'm looking for investors, and technical engineers, all guys welcome. Thank you.
Good evening, everyone. My name is Maxim Hefes of NYTM. My software company helps companies with technology operations, and probably we all guess what we will be doing in software engineering space in the next couple of years. But because like LLMs give you different solutions and AI give you different solutions, but certainly they would not guess our mind in near future. So like operations help you, operations as code give you ability to further advance your technology using AI as well. My ask is like I have a startup using this solutions framework, and we're glad to help you with reliability program as well. Just get in touch, please. Thank you.
Hello, everyone. My name is Janae Jones-David. I'm from Vouch Insurance. I work on the strategic sales for life and science companies. We do have a few of the companies that went up to demo. They are insured with us. But we help startup companies all the way from from pre-seed to IPO. We help them with product liability. We help them while they're doing testings and clinical trials. But for the most part, I work in the life science sector.
Hello, everyone. My name is Rudy Weinberg, and I'm an electrical engineer. I have experience with hardware, board bring up, testing, design, microcontrollers, electric motor control, kind of just anything hardware. That's my thing. And I'd love to join a space team that has a mission, that wants to make the world a better place, that wants to help us move forward into space. And I'm looking for opportunities. So if you need someone, please let me know. Thank you.
Evening, everyone. My name is Daniel Sukuchinyai. I'm currently working on a startup called RIN. It's basically a software for real estate. What it does is that it helps with renovations. Basically, you upload an image of a property in need of renovation, such as the walls, and you can upload multiple images at once. And what the AI, and through AI analysis, you can be told by AI how much you need to invest in renovation and how much you can then get an ROI, return on investment. And also, it can give you a list of contractors within your own budget, so that way you don't have to struggle with finding someone within your budget. Basically, it's your all-in-one real estate AI assistant, a 24/7 assistant. And just today, my team and I, we got our first prototype running. Thank you.
Hi, good evening, everyone. I'm Tobias from Germany. You can notice from my very thick accent. And I'm working at a startup idea that is a little bit in the same sphere. Because if we think about AIs, every AI talks in a different way. And there's a huge topic around interoperability, like how to make different AIs talk to each other. And I just moved to New York, and I'm looking to connect with potential collaborators, co-founders, researchers in the LLM space, and would be very happy to meet you. Thank you very much.
Hey, good evening, everyone. My name is Christopher Ulrich, and in my free time, I am the founder of Offworldly, offworldly.org. We are essentially, what I'm trying to build is a STEM resources and trajectory hub, bringing together resources that I believe are hidden in plain sight. As part of that hub, which is a work in progress, I'm looking to partner with folks who are involved in STEM, whether that is aerospace or we also don't want to leave out the A in STEAM for arts as well, so you can fall into any STEM category. As part of that, I'm building a podcast, which is the storytelling platform of Offworldly. You could find us on YouTube at Offworldly STEM. And yeah, looking to collaborate with anyone in the STEM field. Thank you so much.
Good evening, everyone. I'm Shri. I'm currently a student at Columbia University. I'm pursuing my master's in computer science. And I previously worked in the Indian Space Research Organization as a post-quantum cryptography expert. And here I'm continuing my quantum exploration in cancer research. And I'm looking for opportunities for people who are working in an intersection of quantum, cryptography, and especially my favorite, AI. And I'm looking for opportunities. I'm deeply interested in space tech. I have also previously built a 3D immersive, highly simulated space, which exactly replicates all the space features like the radiation, the temperature, the terrain, to train your models and bots. So that's something I built for Polygon, a blockchain company. So if anybody's interested to collaborate with me, I'll be in the room. Please hit me. Thank you.
Hi, how are you? My name is Elizabeth Kay. I'm representing Fuchsia. We are a Destinate sponsor, Department of State Destinate sponsors on J1 internship. So we have interns from mainly Singapore and Hong Kong coming for the summer, all semester basis. Any startup company that might be interested in taking on our interns, please contact with us. Thank you.
All right, thank you, everybody. And we even have 2 minutes left. Amazing. All right, so before I conclude, I want to thank Malcolm, Evan, Devin, and all of our demos tonight. You guys are amazing, and thanks for all your help in putting this together. That concludes things for tonight. Our next meetup is going to be on Monday, April 13, when we're going to focus on health tech. And registration will open soon. We hope to see you there. And that's it. The bar and the food are back open. Go eat, drink, and connect, okay? See you next time.
I'll fill my heart with song and
Reviens dans un style différent. No limit. Et on dit quoi? Et on y va. Baila conmigo, que yo quiero bailar contigo. Baila conmigo, que yo quiero bailar contigo. Baila conmigo, no limit, yo quiero bailar contigo. Baila conmigo, que yo quiero bailar contigo. Attaque de manière spéciale dans un but bien précis. 1 pour les vacances, 2 pour la danse. Troque ton pour un jet ski et là tu vais ski. Pas le temps de plaire, je suis en manque de rayons solaires, l'air de rien. Je suis le genre de gars à qui il faut sa dose de sun et sa part de sun. D'être à qui je suis avec une pointe de fun. Ay Dios mio, Melka devient loco. Pas de chaleur en vue, mais putain c'était frio. Je suis comme ça, j'y peux rien, pur méditerranéen. Fier de l'être, au moins y'en a un. Sur ce morceau, je prends mon pied, je me fais un kiff trop stylé. Si t'es pas down, à toi de filer. Sur un air de salsa, via Puerto Rico, Cuba, Dominicana et Las Malas. What? Ha. No limit, yo, no limit, yo. Conmigo. Hola, quoi? Melka revoilà, balayant tel un ouragan, chaque fera. L'alliance en tournée, stop sur une job là, stop pour une reste, donc stop, on s'arrête là. Muchacha, mira, l'ombre qui vient là, petit à petit, so step by step. Plus de monde, c'est donc plus de bombes. Plus de gens sur une track qui grondent. Et puis t'es qui toi, t'es qui là? Je bois pas, je fume pas, je kiffe Cuba. Mais le cigare, je smoke pas. Révolutionnaire, reste-toi, appelle-moi Che. Pas de limite, la preuve écoute ça. J'ai plus de style qu'une diva au Brésil. Mon flow frappe fort comme la frappe de Ronaldo. Malgré ça, go, je kiffe Rio. Étoile 51 solo. Porto Rico, loin de Porto Vecchio. Porto Rico, directo, Santo Domingo, fiesta, gogo. Alliance kiffe ça, absorbe ça. Pro du clando, pro du style, fils à fils là. No limit, yo. Yeah, yeah. Conmigo. Yeah. Ha. L'alliance no limit, yo. Et on dit quoi? Fab comeback. Yeah, yeah. C'est comme ça et pas autrement. Yes. Todos, todos. Yeah, yeah. Donc c'était l'alliance une fois de plus, encore rien que pour toi. Pur remix salsa.
Like a hippie booming with constellations. Can you read my fortune? With darkness in your eyes until the morning. With our arms open, cause I can keep falling through kaleidoscopic skies. You said trip, you can dip, follow all the yellow bricks. Take the top off your lip like it's 1966. Let's just sing lucid dreams, kinda taste like gasoline. You're myself into the chemical. Hippie booming with constellations. Can you read my fortune? With darkness in your eyes until the morning. With our arms open, cause I can keep falling through kaleidoscopic skies. You said trip, you can dip, follow all the yellow bricks. Take the top off your lip like it's 1966. Let's just sing lucid dreams, kinda taste like gasoline. You're myself into the chemical.
Oh, hippies know how to party. Oh, hippies know how to move. Oh, hippies know how to party. Oh, hippies know